Lesson 13, Subatomic Heavyweights. This lesson happens to be the class notes for isotopes, and we're going to look at how isotopes differ from the regular atoms we've looked at in class. So it's important to keep remembering to have a periodic table in front of you and to think about the protons, neutrons, and electrons that are inside of each atom. Take a minute to think about how to calculate the number of neutrons in an atom. The chem catalyst, or the starter for this lesson, is talking about a chemist who investigates a sample of lithium, and he found that some of the lithium atoms have a lower mass than other lithium atoms. The chemist drew models of the two different types of lithium atoms as shown on the following slide. So when you look at the two atoms, we've got the lithium atom on the left, and on the right is another lithium atom. The problem with this model in the drawing is that it's really hard to tell the white or lighter colored particles in the middle than the dark ones. So what we're looking at here are the dark ones. So on the left-hand model there are three dark ones. On the right-hand model there's also three dark ones, one here, one here, one here, and then there are four what should be white ones. This one, this one, this one, and this one are four white, and on this one, and this one are three white. So the question is, first off, ask yourself which of these colors represents number of protons. And remember that protons is the identity of the atom. So if you look at lithium on your periodic table, the atomic number is 3. So in this case, these three dark ones and these three dark ones are what represented as a lithium atom. So the other ones, the whiter, lighter ones, 1, 2, 3, and 1, 2, 3, 4, represent neutrons. So it says, what's different about the two atoms? Think about that for a second. What's different about the two atoms? So if you look at the differences, you can see that it's not the electrons. They all have the same electrons. They both have the same electrons because they're both lithium atoms in their neutral state. They both have two shells, and if you look at lithium, it's in period number 2, so there's the two shells. Lithium is also a group 1 element, which means it's going to have one electron in its outer shell. And so the only difference is number of neutrons. It has 3 protons each, and then so this one has 3 neutrons, this one has 4 neutrons. What's the atomic number of each element? So they're both lithium, they both have 3 protons, so the atomic number is 3. What's the atomic mass of each? Now there's where the difference is going to be. The mass number of each element or atom is the protons and neutrons together. So when you see this one, we have 3 protons, 3 neutrons. So the atomic mass of the atom on the left is 6. The atomic mass of the atom on the right is 7. We have 3 neutrons and 3 protons and 4 neutrons. So the atomic mass is 7. So we have lithium 6, that's its identified by its mass, and lithium 7, identified by its mass. So our question is, how can atoms of the same element be different? So we just seen that the number one difference can be in their mass. So by the end of this, you should be able to define an isotope and write and interpret the symbol for a special isotope. Should determine the average atomic mass of an element based on the natural abundance of isotopes of that element. And while that sounds pretty confusing right now, natural abundance means how much is out there in nature. So there's more of one form of lithium out there in nature than the other. So there happens to be more lithium 7 than lithium 6. And the last thing is we're going to predict the number of protons, neutrons, and electrons in the most abundant isotope of an atom based on average atomic mass. So now we're going to prepare for the activity. So make sure you're with your lab groups, that you have something to write with. You'll have a lesson 12 worksheet in front of you. You need a periodic table in front of you. Take a few minutes to get ready.